Hello and welcome back, friends. In this video we'll go over squares and square roots and discuss the division and prime factorization methods of finding square roots of numbers. Fair enough? Okay, let's move on. So coming to squares, the square of a number is obtained by multiplying the number by itself. For instance, 100 is 100 squares, 100 times 100. 10 squares, 10 times 10, 75 squares, 75 times 75. And perfect squares are squares of whole numbers. For instance, as I've mentioned below, 1, 4, 9, 16, 25, which are nothing but squares of 1, 2, 3, 4, 5, which are whole numbers, are all perfect squares. Now let's look at understanding square roots. There are two methods that I'll be going over in this video. The first is a prime factorization method and the second is the division method. Let's look at the simpler method first, which is the prime factorization method that is shown in this slide. So we're looking at a number 1764. Off the top of your head, it's difficult for us to determine what the square root is. So we go ahead by solving by prime factorization. As you know, the prime factorization is determined by finding the prime factors of the number 1764 and simplifying it further and further until you get the number that cannot be divided any further, or until you get 1. So based on the prime factorization method, we get 2 times 2 times 3 times 3 times 7 times 7. So it turns out that every prime factor that we've identified for 1764 can be paired with an equal prime factor. So what we do is we group the similar prime factors. We group the 2's, we group the 3's, we group the 7's. So taking the square roots on both the sides, we can eliminate the 2 from the 2 pair, 3 from the 3 pair, and 7 from the 7 pair, giving us the square root of 1764, which is nothing but 2 times 3 times 7, and that is 42. And this is your prime factorization method. Okay, simple enough, right? Now let's look at a variation of this particular method, where you're asked to find the smallest number which, when multiplied by a given number, gives a perfect square. Okay, now what we have to do in this scenario is we take the number that we've been asked to multiply with to find a perfect square, and we find its prime factors. Similar to what we did before, we get the prime factors for 882. We also follow the method of grouping the similar factors. On grouping similar prime factors, what we get is 3 and 3 can be grouped together, 7's can be grouped together, but then we are left with the number 2, which cannot be grouped with any other equal factor. So that implies that the smallest number that 882 should be multiplied with is 2, because once you have 2 on both sides, you get a perfect square, and that's what they're looking for. So your answer is 2. Sweet. Okay, now moving on to the other method, which is the division method of finding a square root of a number, or as well as a number with a decimal. This is a little tricky, so just please pay close attention to this particular method. Alright guys, we will tackle it one step at a time. Now the number that we've been asked to find the square root of is 123. I've color coded the slide for a reason. That way understanding is going to be a lot simpler. So what we have to do in this scenario is we start in pairs of 2 from right to left, before and after the decimal point. So we group 2, 3 together, and then we're left with 1. on the left side of the decimal point, and then we group the zeros together. Okay, now let's start with the number 1 that we have here. Now we have to figure out what is the nearest square of this number that is less than or equal to 1. Okay, based on that question would be nothing but 1, right? 1 square is less than or equal to 1. That answer, we move it to the top, and then what we do is multiply this particular answer that we obtain, which is 1, we multiply it by 2 and bring it to the left side down. And that's why I have 2 here in bold, because we multiplied 1 times 2 to get 2. Now we also bring 23 from this end, the right side, and bring these 2 digits down. Okay, so what we have is 2 and 23. Alright, now the next step to do is we find out a number x which satisfies this formula, which is this particular number or digit should be such that 20 plus the digit times the same digit should be less than or equal to the number we have on the right side, which is 23. So what would that number be? 21 times 1 is 21, and that is less than 23, right? Yes. Now we can also look at 22 times 2, but 22 times 2 is 44, and 44 is not less than 23. So the answer is 1, right? So once we get 1, and we've determined that 1 is the right answer, we put that 1 again on the top. We do 21 times 1, giving us 21. That comes here. We subtract 21 from 23. We're left with 2, right? And then we take the 2 zeros down here, and we put the decimal point at the top. We follow the same process here. What we did before was we multiplied 1 by 2 to get 2. Now that we have 11 at the top, we multiply 11 by 2, which is 22, and it comes here on the left side down. Okay, and then we have 200 here on the right side. Now we follow the same process. We find a number x such that 220x times x should be less than or equal to 200. However, if we start with 221 times 1, that gives us 221, and 221 is already greater than 200. So that doesn't meet our criteria. So in that scenario, we are left with doing nothing but adding a 0 here after the decimal point, because there is no such digit that meets the criteria. So that's why we put a 0 here, and we take the next pair of zeros down. Okay, so now we have 220. Since we put the 0 here, we have to put a 0 here as well, so because it's 1110, and now it becomes 220. So 220, we follow the same methodology for 220 as well. So 220x times x should give us a number that is less than or equal to 20,000. So it turns out that 221 times 1 is going to be 2201. 2202 times 2 is going to give us 4404, and then going all the way up to 9 gives us 2209 times 9 gives us 19,881. So that is the number which is the closest to 20,000, but at the same time is less than or equal to 20,000, and that's why we put 9 as the answer here at the top. Subtracting 19,881 from 20,000 gives us a remainder of 119, and this is our answer at the top, which is 11.09. So this is it, folks. This is our division method. It is a bit complicated, but it follows a definitive pattern. You just have to keep practicing this over and over with other numbers, and I'm sure you'll be an expert at it. Cool. Thank you very much. Hope you enjoyed it. Please give your thumbs up as well as subscribe to my channel. Looking forward to seeing you in another video very soon. Thanks again.